Today we're doing section 2.2, day 2, and we're going to be again graphing quadratic functions just in standard form. So standard form, and this is for real standard form. I don't know again why the book called the other form something different. So standard form is f of x equals ax squared plus bx plus c. So there's some similarities, but there's some differences along the way. So similarity is that a still determines if you're opening up or down. Your x-intercepts, you are still setting it equal to 0. The way we solve will be different, so I might have to use quadratic formula, or I might have to factor. My y-intercepts, I still am going to be evaluating the function at 0. What will be different is our vertex. So to find the vertex, we use this little formula, negative b over 2a. And once I get this value of negative b over 2a, I'm going to plug it or evaluate the function at that value. So this looks a little confusing, but all this means is I find this x value and then I plug the x value into the function to find its matching y value. So we're just going to go through one example of these because, again, this is something we did last year, so we should be okay with this content. So for our first example, our function is f of x equals negative x squared minus 2x plus 1. So my a value is negative 1, so my parabola is opening down. To find my vertex, I'm going to do negative b over 2a. So I have negative of a negative 2 over 2 times negative 1. So I'll get 2 over negative 2, which is negative 1. Now I need to evaluate the function at negative 1. So I have negative of a negative 1 squared minus 2 times negative 1 plus 1. So in the first part, I need to do exponents first. So negative 1 squared is 1. But I just have to divide by that negative. The middle term will turn positive. Those ones will cancel and I'm left with 2. So my vertex is negative 1, comma 2. So now to find my x-intercepts, I'm going to set this function equal to 0. So I have negative x squared minus 2x plus 1. So here if I was trying to factor, I'm multiplying, figuring out 1 multiplies to be negative 1 and adds to be negative 2, and that's not going to be anything, so I need to use quadratic formula for this. So I'll have negative of a negative 2 plus or minus b squared minus 4 times a times c all over 2a. So underneath the radical, I'll have 4 plus 4, which is the square root of 8, which breaks down to be 2 root 2. So putting it back in the problem, I have 2 plus or minus 2 root 2 all over a negative 2. So to simplify this, when I divide it out, I'm going to have negative 1, and we switch this to say minus plus root 2. So I essentially divided all three of these values by negative 2. Now, this really doesn't mean much to me, so I would use a calculator. I have negative 1 minus plus, and the square root of 2, I'll tell you in a second, is approximately 1.41. So negative 1 minus 1.41 would be negative 2.41. And then negative 1 plus 1.41 would be a positive 0.41. So those are the x-intercepts that I want to use. And to find my y-intercept, I plug in 0. So I'll squeeze this up here. So when I plug in 0, I'll have negative 0 squared minus 2 times 0 plus 1. So 0 minus 0 plus 1 is equal to 1. And if you remember from last year, your c values always represents your y-intercept. So here's all that information just on a different screen. So I know the parabola should be opening down. My vertex is at a negative 1, 2. My x-intercepts are 0.41, so that'll be roughly around there, and a negative 2.41, which would be about there. And my y-intercept is 1. So I should, based on the fact that I know this is my axis of symmetry, I can add that final dot, and here is our parabola. So that's all for today. We'll do some practice on graphing in standard form, and then the ultimate goal is to apply this material to word problems.